Okay, everyone, we're going to get started again. You have to be sitting down, so otherwise we're going to get shut down. So if there are spare seats where you're sitting, can you just raise your hand so people can see where to go? Don't be shy. You can even sit in the front. Oh, not on that table. Don't sit. Oh, sorry. All right, we're getting towards the end of what's been, I hope you think at least, I'm a little biased, but what's been an absolutely wonderful day. We've had 2 great keynotes already, and we're about to have a third. No pressure there, Chris. Chris Wiggins is our last keynote for the afternoon. He was appointed the New York Times Chief Data Scientist in 2014. He's an associate professor in the Department of Applied Physics and Applied Mathematics at Columbia University, a member of the Columbia's Institute for Data Sciences. Well, we won't hold that against you. And a founding member of the university's Center for Computational Biology and Bioinformatics. He's also a co-founder of Hackney, a nonprofit which has hosted hackathons and a structured summer internship program at New York City startups. In 2014, he was elected a Fellow of the American Physical Society and is recipient of Columbia's Avenias Diversity Award. His research focuses on applications of machine learning to real-world data. And just on a personal note, I guess it was over a year ago now, I had Chris come to the NIH when I was there, and he actually not only did give a fantastic talk, but he also did the impossible. He moderated a session between Harold Varmus, who's a Nobel laureate and former director of NIH and former director of the National Cancer Institute, Francis Collins, who's a National Medal of Science winner and the director of NIH. And it all went very smoothly, so we thank you. I still thank you for that very much. Please welcome Chris Wiggins.
Thank you, Phil. Thank you, Phil. Thank you very much, Phil. Thanks for the invitation, and thanks to all of you for staying till the end. So, as advertised, I'm Chris Wiggins, and I split my time between Columbia and the New York Times, and Hack NY, a nonprofit I co-founded. And I'll tell you a little bit today about how I got that way and how we think about data science at the New York Times. The meta lessons I hope we can learn are things that I've seen that industry can learn from academia, and a few things that I think academia can learn from industry. So to start, I should say a little bit about how we think about data science at the New York Times. So I'm kind of orthodox. If there's some founding documents around something, I like to think about what those founding documents were and how they thought about it. So there are some original usages in my mind of data science. I'll go way back to start to this diagram that probably many of you have seen before from proud son of Virginia, if I understand correctly, Drew Conway, who's been a data scientist in New York City for a long time. And way back in 2010, when he was a graduate student at NYU, he was trying to summarize some of the conversations he was hearing in New York City about data science, which he heard as the applications of machine learning to a particular domain. So machine learning has been around since 1959. Some universities, it's actually its own department, and it's a combination of computation and statistics, but applying machine learning to some particular domain, working with people to reframe their questions as machine learning tasks, executing the machine learning, and then using the output of that machine learning to reveal some science or some domain expertise to somebody is a challenge. And that's how Drew saw data science. Some of the things that are not usually discussed in this diagram on the lower left is the danger zone. The danger zone is not to be ignored because if you torture the data, it will confess to anything. So you really need to go to data with some sort of principles. Otherwise, you'll find yourself just proving whatever the CEO wants you to find out or whatever you're funded to find out. You need to have some principles when you deal with data from complex systems. And I should say hacking skills to Drew doesn't mean breaking into things. It means the original definition of hacking, a creative solution to a technical problem. So 2010 might seem old for data science, but there actually are even older usages of data science. Here's a foundational document for the definition of data scientist as a job description. Jeff Hammerbacher is widely credited with creating data science at Facebook. He went to college with Mark Zuckerberg, and after he graduated from Harvard, he did financial services for a year and got bored, called up his friend Mark and said, "Mark, are you doing anything interesting?" And Mark said, "Yes, I have lots of data. Come help us make sense of it." So after 4 years, Jeff had retired and had some time on his hands and wrote this essay about data scientists as a job description, as a job title they made up at Facebook. And so he describes in this essay from 2009 how they were thinking about it probably 2006 through 2007. And he said, at Facebook, we felt like traditional titles, business analyst, statistician, engineer, research scientist, didn't quite get it, because if you're on the team, you might be building a multi-stage processing pipeline in Python, designing a hypothesis test, performing regression in R, designing and implementing an algorithm or some data-intensive product or service in Hadoop, and communicating these results or analyses to other members of the org in a clear and concise fashion. And so we made up the term data scientist. And I have to say, it's really fun to look at this description from 2007, published in 2009, and compare it to what we do in the data science group at the New York Times today. So certainly, there's a group that builds multi-stage data processing pipelines. Those people are now called data engineers. And I'll talk more about the data engineering skill set later. Certainly, people might be doing some hypothesis testing, but a lot of that happens particularly around A/B testing in a group which is now called the data analysts. Regression analysis, we certainly do, although we do it largely in Python rather than R. I think Python's gotten much better since this was written. We definitely build a lot of data product, and that's one way we think about data scientists at the New York Times, is we have a group that ships to prod, which is a software engineer's way of saying we actually build things that people use. And we don't have to think so much about Hadoop as we did 10 years ago, because at this point, the fact that you have a distributed data store is often transparent to the analyst or the data scientist in ways I'll talk about later. But the most important thing, my favorite thing about this paragraph, is the last part where he says, communicate the results in a clear and concise fashion. Earlier today, we were talking about soft skills. That is certainly something we look for in the data science team at the New York Times. I'm looking for people who I can drop in a room with marketing or drop in a room with the CEO, and you have to be willing to work with somebody who doesn't speak machine learning, doesn't speak calculus, a real normal person, and speak normal person with them. And communicate, it comes two ways, right? Communicate means that you're able to listen to them speak like a normal person, and the onus is on you to figure out what that means in terms of a loss function or a machine learning algo. And then you also have to be able to explain to somebody else what your algorithm does. Last week I was in a meeting with some other people at the New York Times, and somebody brought up an algorithm, and they said, is it just too complicated to understand? I said, no, absolutely not. I do not want anybody at the New York Times to think that something we do in our group is too complicated to understand. That is one of the things that I think people in industry are looking for when they hire a data scientist, is they want somebody who's willing to make their work interpretable. Okay. This is a bonus slide for academics. Normally at an industrial context, I wouldn't go way this far back, but there actually is an even older usage of the term data science. Way back when, in 2001, 16 years ago, there's this nice article by the heretical statistician Bill Cleveland. So Bill was coming from a I say it like he's dead. Bill's still alive. So Bill's coming from a particularly applied background, and he was writing from AT&T's statistics group. And AT&T and Bell Labs has a long history of a very modern outlook on learning from abundant data, and every 10 years or so writing an essay about how wide the gap is between statistics as it was understood at Bell Labs and statistics that was being taught in universities. So this is one such article, which Cleveland told me did not go over well at all. But he wrote this article about how different academic statistics was from what he saw in Bell Labs at the time. And he said, look, let's just make up a new field. Let's just call it data science. So go read this article sometime. And other than the Hadoop and a couple of other novel things, you'll see a mindset that really resonates with what people are looking for now when they hire a data scientist. OK, so the way I think about data science is very much like these original foundational documents. I think about it as the art and craft of applying machine learning to some particular domain. And just like Jeff Hammerbacher wrote, one of the most important skills is your ability to communicate the results clearly and in a concise way to everybody else in the org. Now, that's data science. What on earth does this have to do with the New York Times? So many of you may wonder, why does the New York Times have any data? And that's reasonable because for many of us, the New York Times in your brain looks like this. You hear New York Times and you think, oh, that's a newspaper. Here is a birthday picture of the New York Times from the day it was born in 1851 as the New York Daily Times. where would you put a data science group in the New York Times? So to explain that question, I have to show you the organizational chart for the New York Times. Here's the organizational chart for the New York Times. The New York Times is a place whose raison d'etre is a craft. There's the craft of journalism. And church is the people who defend and possess the craft of journalism. And state is everything else, sometimes called the business side or the B side. And I am quite solidly on the business side. So to make that clear, sometimes I tell people I do data science at the New York Times, and they say, awesome, I love your interactives and graphics. And I say, those people are great. Those people are in church. So there's a set of people who do graphics. Those are journalists. They think about storytelling. They think about creating things that you will see. That's not my people. Or they say, oh, you do data science, that's great. I love the upshot, and I love data journalism. And I say, those people are awesome. They're great. That's not what my team does. Those people are journalists. They produce stuff that you see. My stuff is in state. We build stuff that you probably never see. We build internal data products, and I'll try to show you some examples of those. And in particular, within state, we live in a separate group called data. So there is a data group, reports directly to CEO, and we try to solve problems throughout the company. Okay, so again, I haven't really said why the New York Times actually has data. The New York Times has data for an unintended consequence of creating a website. So the New York Times has a website. The New York Times put a website online in my birthday in 1996, and they reported on it with the quaint headline, "The New York Times introduces a website." And the consequence of that is that now lots and lots of people every day go to that website. So you can go to nytco.com, and you can see statistics about how many people have been to the website in the last hour, the last day. By the way, this is a picture of the lobby. And the lobby art there was written in Python by my colleague Mark Hansen, who's at Columbia. And what's interesting about all those people going to a website is, unlike broadcast, so unlike listening to a radio or watching a broadcast television where the photons come to some device and then some transmogrification makes it go into your ear, every digital interaction is actually a conversation. Whether or not you know it or not, your phone is constantly having a conversation all the time, telling everyone what you're doing. So I'm not actually violating any NDA to tell you this. If you open up any civilized browser, like Google Chrome, for example, and you go to the developer tools, and you look, well, what sort of data am I sharing with all the websites I go to? You'd like it upper? Closer? OK, thank you much. So go to developer tools, and you can see, well, what information am I sharing with all the websites I go to? Here's a website about sports ball from 2014. You can see, well, it tells the website, the browser, the OS, where you've been before, how many characters you've read, how long you've been on the website. Right? So every time you're visiting any digital property, you're actually having an abundant conversation all the time, whether you know it or not. Lest you think the New York Times is the most technologically sophisticated company in the world, you might wonder sometime why Google knows how many people have been at Blue Bottle Coffee in Brooklyn at every hour in the day. And it's not because they have a focus group. It's because they give you free phone and free Gmail and free documents in exchange for collecting all of your data all the time. So enjoy. This is not, again, a totally new observation. There's a good quote about this phenomenon, which is sometimes called data exhaust. The quote is, social activities generate large quantities of potentially valuable data. The data were not generated for the purpose of learning. However, the potential for learning is great. Any guesses what year this quote was written? Sounds like a pretty modern quote, but it's actually from 1993 by John Chambers, who created S, which was the forerunner of R at Bell Labs. So again, people at Bell Labs were already thinking about how much they could learn from everybody's telecommunications metadata way back when. And they were sort of the Facebook and the Google of the day, right? They had all the computers, all the data, all the nerds. So when people started making websites in 1996, the thinking about a website was, well, this will be our online presence, and it is. But for many companies, they realized soon thereafter that the web is actually a microscope for understanding your entire audience at scale, which is what web companies that have websites, are aiming to do when they try to make sense of digital interaction data. So that sounds like a really interesting academic problem, where by academic I mean useless. But I assure you that the New York Times is not interested in this for academic reasons. To make sense of that, I'll show you a second unintended consequence of creating a World Wide Web, and that is this graph on the right where you see a clear effect. So let's zoom in on this effect. Like if you work in complex systems, you're really happy when you see a graph with something like that because you're like, that's a clear effect. So what is the effect? Well, the y-axis is money, and the x-axis is time. And specifically, this is advertising money spent in newspapers in the United States starting in the 50s. And you can see that for a long time, things are looking really good. And in the 80s and 90s, everybody's flying business class. And then 2004, all the money just goes away. So 2004 through 2010, there's just a huge change in advertising. And the consequence of that is, for the last century or so, the craft of journalism has been coupled to the business of newspapering. And in that business, the main driver of the business is advertising, and that all went away. So if you think about a startup as a temporary organization in search of a scalable and repeatable business model, every publisher is now a startup. New York Times, Vox, Circa, Buzzfeed, all of us are trying to figure out, does there exist a scalable and repeatable business model for journalism in 2017? And we really do not know as a species. It's an exciting time to be in journalism. The thing you might wonder is, where did the money go? And it went to Google. So you can look at this graph. This is a graph of money that has Google in it, and you can see pretty much all the advertising revenue is shifted over to Google. And in fact, if you make a more modern graph, it's like Google and Facebook basically have 95 cents out of every dollar for digital advertising now, which is why it's a challenging time. So the New York Times takes this challenge seriously. There's a nice report about it called the Innovation Report. This is a document written by journalists for journalists, if you ever get your hands on it, which you can because it was promptly leaked to Buzzfeed, so everybody now has it in full color. It's a lovely document, and one of the things that the document recommends is that there should be room for us to put to work all of our data, and that our data should be useful for helping us both on church and state. So briefly, that's how I think about the data science group at the New York Times. We are a group that aims to develop and deploy machine learning algorithms to assist in business and newsroom challenges. So let me try to illustrate some of those learnings. So when I tell people about the types of different projects my group does, I tend to do things, I tend to use words that are meaningful both inside my group and outside my group. I try not to use too much language that's only secret speak for my group. And that is, I tend to tell people that we do a combination of descriptive model, predictive modeling, and prescriptive modeling. Which sounds a little complicated, so I want to flesh that out. And first of all, for people who are in intelligentsia, inside my group, I tell them, actually, these are just unsupervised learning, supervised learning, and reinforcement learning, if you happen to come from machine learning as a background. But that is those are words that most people don't know, but these words, predictive, prescriptive, descriptive, those are words that normal people use. Here's an example of normal people graphs. Gartner is a company that CEOs pay money to tell them what is the deal with data, and they put out this graph a few years ago in which there are different types of analysis, and prescriptive analysis is the thing that's both valuable but also really difficult to do. Actually, I got this document from Michael Littman, who said he liked the document because the thing he does is both the most difficult and the most valuable, because he does reinforcement learning. But yeah, that sort of maps on things that we think about as machine learners into a language that normal people would use. So let me give you some examples of that. To be a little bit more abstract about it, or a little bit mathematical, I tend to think about problems that we have where somebody gives us a large table of data and says, here's all the customers. Here's everything I think is important about the customers. Summarize them for me. Can you say that these people are really NASCAR moms and urban millennials, or some segments are like that? And I say, okay, that's a job for clustering. That's a job for unsupervised learning. You want a simpler description. Sometimes people come to me and they say, here's all the customers, and it's a big table, and then there's one column that's the sacred column, and I want to predict that column from every other column. And I say, okay, well, what you really want me to do is you want me to predict things for you. And that's a supervised learning task. Or some people gives me a table and they say, here's a bunch of people, here's everything I knew about them, here's the action I took, and here's the outcome they got, and I want more of that. Well, I say, well, that's really a prescriptive problem, right? You've given me a bunch of things where you've taken a bunch of patients and you gave them different treatments, and now you want to know for a new patient what's the optimal treatment to get that response, or get them to click on an ad or something like that. Those are really prescriptive problems. Let me try to illustrate how different problems that we do in the group relate to those goals. So one example which people, this is one of the few things we do that actually is seen by customers. We do work on content recommendation, which at the New York Times happens in a very limited way. On the lower right-hand side of the homepage, if you scroll all the way down, there's a recommended for you widget. And to do that, we actually make a model of the stories. So we make a model of the stories in terms of topics. Several of the talks I was at today actually mentioned topic modeling. So we do a type of topic modeling for stories. If you've never thought about topic modeling, it goes like this. You can take a bunch of content and break it into different topics. You can allow mathematics to show you what different topics stories are made out of, so that a story about a movie review is quite clearly about arts, but not politics. A story about Iraq is clearly about politics, but not art. But something about the Frick Museum renovation running into troubles with the government, that's sort of between the two. How do we do that? Well, we do that using generative modeling. So earlier today, somebody was mentioning LDA, latent Dirichlet allocation. LDA as a generative model is sort of a subpart of this model. This is sort of a bigger, worse model in which we incorporate also whether or not people clicked on things. So that allows you to build a topic model that gives you information about who's going to enjoy which content. And that's the kind of thing that we use to drive a recommendation algo. So we're building a model that allows you to describe the text, but in the end, we want to answer a question that's a decision support question. Somebody wants to know which content should we show to which people. So in a way, it's a prescriptive task. Let me show you an example of a predictive task. So a predictive task might be the New York Times, in part, because of the death of advertising, is moving from an advertising model to a subscription model. So if you're going to move to a subscription model, you really want to know what is it about our content or the way people engage with the content that make them likely to become a subscriber or likely to remain a subscriber. A reasonable thing to do, therefore, is to build a model for which customers are going to leave your subscription or which people are going to become subscribers. So this is sometimes called the funnel if you come from marketing or business. And then the bad red arrow is people going from a loyalist to canceling their subscription. So one of the first things, in fact, literally the very first day I was there for my sabbatical, I said, we really should build a model about how our subscribers cancel. And of course, you would like to have a model that's not only predictive, but also interpretable. So the people I work with in marketing want to know not only who's at risk, but what are the risky behaviors. And so we can do that. We can try to build a model where we can actually reveal what are the covariates that are good leading indicators for loyalty. I can't really tell you what they are. But that mindset about doing that came to me because I had already been doing that in machine learning applied to biology. So like 15 years ago, when people started looking at microarray data, one of the things that a yeast biologist might want to know, for example, is not only what makes genes, which genes are going to go up and down or turn on and turn off, but why. Can you tell me what are the DNA binding sites upstream of the coding region that convey predictive power? So that was the kind of work that I had done in wearing a prior hat. But again, a lot of the data science task, working with a person who's not a quantitative person, but who has lots of domain expertise, and suddenly finds herself or himself awash in data, and trying to build a model that balances predictive power and interpretability, that happens a lot in the natural sciences, but also in the real world. This is not a new idea. In the late 90s, when people started applying large computational techniques to high-dimensional problems, there was a lot of people realizing there were problems there. There's a great piece about this by Leo Breiman, who gave us random forests. It was a great data science story. Wrote this article about the two cultures. Are you trying to build a predictive model or an interpretable model? And as an example, he said, random forests are A+ predictors, but they get an F for interpretability. But if you make a decision tree, you get an A+ for interpretability. So these are kinds of issues that people have been thinking about for at least 15 years. So again, we can build a model that says what's going to happen to these people in the absence of treatment. But for many marketing people, what they really want to know is what's the optimal treatment. So even though I can build a predictive model, what they really want is a prescriptive model. They really want some decision support. Another example of something where we can predict where there's a clear win is around predicting how many copies of the newspaper should go to stores that sell single copies. So there's one that we can get at with no worries about how it affects news judgment. We would like the New York Times not to go out of business. So we can treat that as a machine learning problem. We can look at how many people buy at different stores. We can build a predictive model, and we can deploy it as an A/B test. A/B test meaning different stores get delivered under different algorithms. And at the end of the day, we can scientifically prove how many data scientists' salaries can I save you by using scikit-learn and deploying it via Google Cloud Platform, rather than having a handful of heuristics written in COBOL and deployed on an AS400 machine from the late 90s, which we did. So this is a classic problem called the news vendor problem. But there's a decision support question lying in there too, which is how many copies should we send to all these different stores? So it's a case where we can build a predictive model, but really we're trying to help people make difficult decisions. Another example where there's a difficult decision that's closer to news, in the innovation report, first sentence of the first paragraph is the New York Times is winning at journalism, which again, I remind you, this is a report by journalists for journalists. Second paragraph says we need to keep up with the art and science of getting that journalism to our readers. So we tried to work with newsroom people, editors, to figure out how should we promote our content in ways that would optimize some sort of engagement. So we built the fancy machine learning model, and then we had a product challenge. Again, getting back to Jeff Hammerbacher's paragraph. It's not just enough to write a PDF. If you're going to build a product, you need to think like a product person. So I told this software engineer, you are now the forward deploy ambassador for machine learning to the newsroom. Go down there and interview people and do design thinking and hear their pain and think about their workflow. And we realized that we couldn't get editors to fire up Python, but we could get them to use Slack, because they already use Slack. And if you've never used Slack, it's like a chat program. But what's nice is that you can write bots. So then the editors can interact with this friendly bot. And we didn't call it, HAL 9000, we called it Blossom, because it's like a flower and you pour water on it, it blossoms. And then Colin, the software engineer, whose personality is nothing like a teddy bear, made this non-threatening teddy bear, and it was like a happy experience for everybody. They all got to use this bot, and this bot would tell you if you asked it, which story should I be promoting on which different social channels, or if you wanted to, you could set it to just interrupt you and say, now is the time to promote this story on a social channel. This story is doing really well. So we had to build methods that are not only predictive, but also performant. We didn't necessarily need to worry about interpretability, but we did need the thing to work as a product. Again, there is a decision support question lying in there, which is the decision about what story should I be promoting on which channels. And we did it in a way that was, to speak to an earlier keynote, data-informed but not data-driven. So this is not something where you just let it go and it just tweets for you. This is something where it suggests this is what you should be promoting, but then the person has the option of just ignoring it. OK, so I hope I've illustrated that many times when you work with a normal person is not interested in a description, even if they come to you and say, I want you to build me a dendrogram or a cluster. Really, a lot of the times, they want to help with a difficult decision, like what content should you recommend, or how many copies should you send, or which story should you be promoting. And all of those things, I think, comes back to this idea that a lot of times what people really want is a prescriptive model. They really want help making difficult decisions. It takes more work, though, because you have to specify not only what are the signals you think are relevant, what is it you're trying to achieve, but what are you willing to do to get those people to do that thing. So you have to do a little more work. There's a bit of temporal nature here that a lot of times you have some new data set and you start exploring it, like, who are these customers? Can I describe them in different groups? Then you actually launch something and you have some observational data, you can build a prediction. Then you can think about which widgets you want to turn, and then you can actually optimize those widgets. And of course, it's just like science, right? The same rules apply, that in reality, it's not like, OK, well, I'm done, and now I go home. But really, like, you're constantly learning about the system. And in fact, the system might change. Part of how we do this is to recognize that there are different skills there. So again, getting back to Jeff's paragraphs, there's now, in 2017, a distinct group that thinks real hard about making sure that the data are architected correctly, that they're available, that they're accurate. Those are the data engineers. The data analysts are there, making sure that the A/B tests achieve statistical significance. We build products by embedding data scientists in the groups with which they work. We think real hard about product decisions, which involves design thinking. We think real hard about data governance. We have a special team that's just for making sure that columns mean the same thing in different teams, and also that the right people have access to the right data, and that we're not leaking PII all over the world. InfoSec goes along with that, and to get everybody to work together, we work real hard to make sure that we're not saying anything in some sort of secret language, that everybody knows what we're doing. These three jobs, data scientists, data engineers, and data analysts, are sort of conflated in Jeff's definition from 10 years ago, and I would say a lot of us in academia sort of conflate these things, but at least at the New York Times, those are three separate job descriptions and 3 separate teams. which gets me to the idea that people really matter, and keeping track of people and recognizing distinct skills matters. So what are some of the things that I think academia can learn from industry here? One thing that I think I've learned from industry is if you really want to get anything done in a complex organization, you really need to think about people, ideas, and things in that order. And this is a phrase borrowed from the US Air Force. It's easy for us to think about the thing, like the Hadoop or some sort of technical thing that's concrete. But really, none of that really matters unless everybody's on the same page in terms of what you're doing. And none of that's going to matter unless you have the right people there. So as an example of a thing, we talked earlier in the health breakout about how important it is to get your data correct, like to get your fundamentals right. This is an idea that experts share with you. This is a blog post from earlier this year from Monica Rigatti, formerly of LinkedIn. She was interviewed in the New York Times about a year ago where the headline was something about being data janitors and how much of the work was just making sure that your data are correct. You need to have those fundamentals right, that your data are accurate before you start thinking about all the data flow and the streaming data, before you start thinking about whether or not the data are clean and ready for modeling. Then you should think about analytics. Then you can think about a little bit of optimization. Then you get to think about your fancy AI. But there's no point in thinking about fancy math until you've made sure that your data are correct in the first place. Earlier today, somebody was saying, it's hard to hire those people because it's boring. Well, there's a certain mindset of people for whom that's not boring at all. Those people are engineers, which is why it's good that we have a data engineering team, like people who actually care about building things well. And so we're lucky at the New York Times that we have a really good data engineering team populating with people who have engineering mindset. They want to make sure that they build things correctly. So it may be boring to some people, but not to other people. Another thing that I've learned from the New York Times that I don't see a lot of in academia yet, although I think there will be more of, is using deep learning and trying to think clearly about how to use it. And a lot of times using deep learning means doing things in the cloud rather than on your laptop. So as an example of a deep learning thing that we're doing at the New York Times, every time somebody takes a picture, before it goes out to Queens, to the printing plant, it's got to be carefully rebalanced in terms of lightness and darkness and colors. And people do this, and it's very laborious. And that means we have an awesome data set of before and after. And so now we can train a deep learning model to say, OK, well, for this thing, you want to make the brown darker. But for this other thing, you want to make the brown lighter. And so now we're doing that in Google Cloud, and we can do that on thousands of images every day. OK. So again, people often want to know not what's going to happen in the absence of treatment, but what is the ideal treatment. That is, people come to us and they say, I want you to predict who's going to cancel, but what they really want to know is, what should I do to get people not to cancel? So a lot of the things that I think we do in industry, and I think in academia also, are really decision support, but often not too much. That is, there's times that you want to work with somebody, but they have their own craft, right? So people are not interested in having you replace them. They're interested in helping you make them more efficient, right? So you have to really listen to what people want, and you have to listen to what people consider their craft and be respectful of their craft. And part of that is just being respectful to your collaborators. So ideas, I would say, matter more than the things, and none of those things matter as much as the people. The way we've built up a data science team at the New York Times is to hire people from a diversity of backgrounds, physics, EE, Cogs, physical chemistry, and all these people, as I said earlier, ship to prod. So they're coming from a scientific background, but they also know how to write code, and they build things that people can use. APIs, web apps, Slack bots, Gooeys. These people are all able to build code people can use. How do we go about finding those people? Because you can't go to 5 or 6 or 12 different academic departments. We do this by interacting with the community. So again, getting back to something said earlier, 7 years ago, I co-founded this nonprofit called HackNY. HackNY throws hackathons, and we also have a summer internship program where we bring people from all over the world to work in New York City startups. That's been very educational to find out about the culture of software engineering, which turns out to be different from the culture of academic computer scientists. That's been an education for me. Hackathons are OK, and they're not scary. You can bring your kids to them. Here's my kids demoing in Scratch at a hackathon. And the other thing is forming a data science institute, which everyone here knows well. So Data Science Institute at Columbia was launched in 2012. And at this point, there's a research, education, and outreach mission. There's a data science master's program and certification program. There's an online set of courses. There's a master's in data science. These things will not be new here. And there's a focus on entrepreneurship and thinking about how we can make connections between local industry and data science classes, including not only training people, but getting people from the real world to come in and help teach things that people in industry want to use. Other academic innovations of the Institute include teaching data science broadly. One thing that the Data Science Institute funded was a class that I co-teach with Matt Jones, who's a history professor, which is like a data class for everybody. We call it Data Past, Present, and Future. On Tuesday, we read great papers from the 19th century or even 2015 about data science. And then on Thursday, we fire up IPython in the cloud, and we give them pre-authored notebooks so they can either execute those notebooks by pressing return, or if they know how to code, they can break the notebooks and learn some data science. That's been very educational for me. We also have a high school class, Explorations in Data Science, which is taught in R. And as mentioned earlier today, all of this stuff is on GitHub. I encourage you to go check out the notebooks. So in short, you want to get things done in any community, whether it's a large company, a large bureaucratic university, or a local ecosystem. Think about people, ideas, and things in that order. I know it's easy to think about the things first, but really you need to think about who are the people who are going to be the glue that puts it all together. And with that, I think I have a little bit of time left over for questions. Thank you very much, Phil.
Comment sections I've seen on newspapers. How you achieve that?
It's very expensive because we use human beings. So it's not algorithmically done. There's actually a lot of people who moderate those things. We have benefited from a partnership with Jigsaw. Jigsaw, part of the company formerly known as Google. So Jigsaw launches lots of programs for good. I was going to say to you earlier, Jigsaw would be a great way to solve the fact that education needs InfoSec. Very few companies have better InfoSec than Google right now, so maybe Jigsaw would like to help these companies not have all of their students' records leaked. Anyway, so the New York Times enjoyed a partnership with Jigsaw recently where we actually built out a very fancy deep learning-based comment moderation system that sort of organizes the comments in such a way that helps a human moderator identify things likely to be good or bad. But ultimately, the way the New York Times does that at such a high quality is extremely expensive. There's a lot of human beings who actually work at it.
Thank you.
Oh, shoot. I'm loud. Sorry. About 10 years ago, as a teacher in a public school, I attended a New York Times seminar. And so we were able to get a subscription to the school, which was part of what the New York Times was doing at the time to get people addicted to it. But also you described, I mean, the newspaper seminar described what you do with the sections and how it's delineated throughout the week and how important it is. But one of the things that I wanted to ask you about was the obituary section and how you morgue people's information. How does that work now, currently? This was like 10 years ago.
How does it work? Well, that's a very easy question for me to answer because in addition to being not on the church side, I'm definitely not in the obit section of the church. So I can't say that I know much about how they do it other than what I read in the New York Times. Yeah. I wish I could tell you more about that, but it's so far away from my location in the org chart, I can't tell you much more than what I read in the papers.
So sorry. I have a question on AI and randomization. So I read the New York Times. I think the New York Times, by the way, is a great periodical. And it's a very enriching experience. But let's say, for example, I've read a couple articles on Harvey Weinstein, Louis C.K., and the AI is saying that, hey, this next article about this next harassment thing is coming up. Where does randomization come in where I just want to break from that sort of serendipitous moment that we once had with print paper? And the corollary too is like on Netflix, you've watched like 4 war movies in a row, but maybe I need a rom-com just to, lighten the mood here of things. And how does that come into play of there is this rich ecosystem of articles on the New York Times that I think in some ways editors want to realize, and I think the public wants that too, and not just to do these constancies of predictive modeling paths that are created or of the articles that we've read historically.
Good. So let me say something general and then something specific. So a general statement is, don't underestimate how random I can make an algorithm, right? I mean, that is a parameter one can tune, and you can easily make an algorithm be pretty real random, including just fully random. The question is, what KPI or what goal are you trying to optimize? And so if a product person says, okay, I want you to build an algorithm that's as addictive as possible, then you'll get one outcome. For example, let's imagine that I had a feed of stuff and I was drawing in stuff from anywhere on the internet. Your grandma, New York Times, Macedonia, St. Petersburg, anywhere. And I wanted to optimize for things that you're likely to share. But we also know that you're more likely to share things that you agree with. Then you're going to end up optimizing for things you already agree with, right? So now let me say something that's more specific to the New York Times. The New York Times is not optimizing for stuff from all over the web. It's not using, even Tabula or Outbrain and putting like Rando sites from other, Rando content from other sites on your webpage. It's just optimizing over the New York Times' own content, and usually only over our last day or two of our own content. And let me now say something even more specific. People often say to me, oh, well, why am I seeing this personalized thing in my app about Louis C.K. or Weinstein or whatever? And I get out my app and I say, no, that app is fully not personalized. There's no personalization happening in the app. So it may be that you feel like you're getting something targeted to you by AI. It's not in the app. So almost all the time when you experience the New York Times content, it's fully editorial. It's fully something that an editor chose for you. Really, the only time, there's only a few venues or product places, points of entry where you experience personalization. And one of them is, as I said, in a section that explicitly says recommended for you. Most of the time, you may feel like you're getting a personalized experience in the palm of your hand, but get out and look in the palm of your friend's hand, and it'll be the same order.
So working for an organization like the New York Times, I'm sure that there are more ideas than your data science team could ever actually work on. And so how do you make that decision about what to work on
Same thing
next?
I do with my research group. I literally, with my research group and with the New York Times, I will write on a board, okay, let's chart out how much time it's going to take you to do that, and then how happy you will be if you do that thing. It's basically effort and impact, right, is a word that a management consultant would use. But we have finite time on the planet, and we'd like to do things that would be happy and give us joy, but we only have finite time. So for any project we're thinking about doing, we have to really try to estimate, like, how long would it take us to get that thing done, and then how much would it help anybody? And then it touches also on management decisions. Like for management decisions, I want to make sure that I have choose projects for people that are a combination of what they're good at, what they want to be good at, and what's good for the company, or good for the scientific community, if it's in the case of a research project. So I do think that there are some basic analyses we can do, because you can't do everything. You're right.
Hey, so I'm a little bit worried about the future of truth as it relates to fake news and everything. I've read that given a person's 2-minute clip, audio clip, you can make them say anything, and we're getting closer with video. What's going to happen?
Oh, geez. It's really hard to predict, particularly about the future. So that's a difficult question. I mean, all I can say is that I think yes, you're right to be worried. I mean, you're really right to be worried, right? Like we have we as a species have done such a good job optimizing for influence, right? And we've done that in the context of online advertising, we've been working on advertising one way or the other pretty real hard as an industry since like the 20s, right? Now it's become, empowered by just an amazing abundance of data, right? Like as I illustrated before with Google knowing how many people in blue bottle companies, we are sort of, many of us are in a post-privacy mindset in which companies with market cap of $500 billion have told us 10 years ago that privacy is over. And for a lot of people, they're like, okay, sure, here's all my data. Getting things that are enjoyable to you is enjoyable, right? And so now we know how to optimize. We as a species, not the New York Times, but we as a species know how to optimize for that. We can do it pretty real well. We've proven that. What that means for truth is a problem, right? Because if I have algorithms that are constantly optimizing for what's going to most influence you, and influence is influence, whether it's coming from somebody who's influencing you for something political or to purchase or just disinformation, that is really something that people need to defend themselves against. I mean, the best I could say is something that somebody else said earlier today, which is we need to educate our students about thinking critically about the content they experience, right? So when you experience some content, whether it's like this or that, right? That there's some algorithm that some person designed, and that person had goals. Those goals may be correlated with yours or anti-correlated with yours, but you need to think about critically. You need to think about what were the goals of the company that's making this product decision, and how does that relate to what I really want from the information I want to consume?
Chris, great talk. It's a little loud, and I love the New York Times, but just wanted to say that. So maybe this doesn't happen. I'm wondering to what extent there's some tension, and you've kind of talked about like not too much with the prescriptive, but to what extent there might be tension in terms of the prescriptions going down a gradient, taking you to another mission, and the mission of the New York Times. So for example, you can imagine that your prescriptions would tell you to change the content in such a way that, for example, just for a bad example, you turn into USA Today or something. To what extent is there a tension, or maybe there's no problem at all?
Nobody wants that to happen. Like the editors and the journalists don't want to be replaced. It happens to be a company for which there exists a craft, and they, like the first sentence of the first paragraph makes clear how they feel about their position in journalism. Like we are winning at journalism. It's not like we really need a data scientist to come in and teach us how to journalism. So they're not, clamoring for somebody to help them pivot away from their news judgment. And I'm not interested in helping them pivot away from their journalism, from their news judgment. And not just because I don't think it would be fine, but I think it would be bad for business. Right? Like I'd like the New York Times not to go out of business. So,
right. I just wonder how you constrain the models. Like, do we run the prescriptions once every 2 months? Like, if you aggressively ran the prescriptions, could they take you down that path?
If you're not careful, sure. As we were saying earlier, again, if I had a news feed that pulled from all of the internet and I optimized for things you were likely to share, for example, we know that you are likely going to get things that you already agree with, right? I'm not the first person to make that sort of Socrates is man, all men are mortal, therefore, and that's pretty real clear logic. But nobody is trying to do that. Most of the projects I work on have nothing to do with even which content to recommend, let alone what type of content to produce. And nobody's interested in me doing that. I'm not interested in me doing that because then there's no moat between the New York Times and other companies, right? Like the New York Times happens to have pretty real good journalists and editors. So there's no point me writing an algorithm that's trying to replace what those people are doing, because then there's no moat between us and another company that can hire a bunch of nerds to generate content and optimally target it, right? So I would much rather than them keep doing the thing for which there is a moat between this company and other companies. We also have what I would call last mover advantage, meaning we as a species now know in 2017 what happens when you pay and promote journalists based on how many clicks they get. So there was a company that actually had a big board in front of the journalists called the Big Board that indicated how many clicks they were getting for those stories. That company was called Gawker, and we know how that story ends. And I assure you that nobody in the New York Times newsroom wants to become Gawker. There's like nobody in the church side is asking me to do that. Nobody on the state side is asking me to do that. I don't want to do that. So there's actually not so much tension around that. Please. Hey. Likewise. Okay, sure.
Okay.
Ooh, whoa.
All right, everybody just relax. wow, this is loud. So having been in the journalism world myself, we used to spend hours in the newsroom trying to come up with the concept behind viral content. We didn't have the data science expertise that you did, but I remember, how many years ago was it that the New York Times actually brought in Buzzfeed experts to chat with you guys around better content? And I remember thinking to myself, I'm nervous that the New York Times is going to turn into another Gawker. So you clearly seem to be in support of viral content, is that correct?
I don't really know what that means, but I can definitely tell you that I'm not aware of any time when people from BuzzFeed came in to advise. And maybe it was before my time.
I think it was before your time.
Certainly Jonah has come in and talked to the board, just to chat with the board. But I'm not aware of any time that the New York Times said to BuzzFeed, teach us how to journalism, as I said earlier.
Okay, well let me.
Here's what Dean says. Dean Vacays, he says, we want our stuff to be read, right? And here's what second paragraph of the innovation report says. We've not kept up with the art and science of getting our journalism to readers. So that, I think, is something that the New York Times is on record as saying. I'm not aware of anyone from the New York Times on record as saying, we are pro-virality.
Okay, well, whatever happened, it's in the past. Where do you think is the comfortable balance between viral content and content that, in your opinion, people should read, even if it might not have the elements of what your Blossom platform would identify as viral?
The framing that I like is one that Jay Rosen uses, which is we should be optimizing for trust. We want to, if we're a subscription service, you want to make decisions, both news judgment and product decisions, based on what is optimizing for the trust of the subscriber. What can we do that would make the subscribers trust us? Another language that the New York Times uses is we want to be a digital subscription service that's part of your daily habit, that people come back to the New York Times. So those are things that I think of as along with Dean Vacays' statement that we want our stuff to be read. I think those are the ways people think about it. Like, what are we trying to do? I've never heard anybody say we want to be viral, but I have heard people say we want our stuff to be read and we want to become part of people's habit and we want the users to trust us. So those are sort of the values that I hear people talk about.
All right, so we're going to have to cut this stuff short. So thank you so much for coming.
Sure.
In appreciation, we have a year's subscription to the New York Times.
All right. Good. My favorite. How did you know? Good.
I can say, I think I speak for many of us in this room, that we've grown up and we cherish the New York Times, and your contributions to keeping it going are most welcome. So thank you very much, Chris. Okay, it's come to that time of the day. First of all, I think we need to have just a few thank yous here. Can I get the DSI team to come up here? You too, Tom. No, you don't get out of this. So can I just offer a few thanks to various people. We had I'm not going to go through a whole lot of names, but we had steering committees that were involved in setting all of this up, and so I thank you very much. We thank Kathy, come on. We, as I mentioned at the beginning, we have support from the Office of the Vice President for IT and the Office of the Vice President for Research. And I want to thank the speakers, panelists, and volunteers. And most of all, our great staff. That's right, we take up the whole stage now. So this is now a team of more than 2 people. It's quite something. So thanks very much. But now, of course, the big moment you've been waiting for is the announcement of the prize winner. And we have that. Can we get that on the screen? Oh, we have. There you go. Oh, so there it is. We have, my goodness, we have. Oh, it's my number. 291 is the winner. Who is 291 here? You have to look at your badge. You? Oh! He's one of our very own, but... I'm absolutely sure that's a coincidence. Do we actually have the gift here? Oh, it's there. Good. You know what's in there? An empty box. All right, so thank you everyone for coming today. I think it's been a really enriching day. Oh, we didn't shake hands, but we'll do that later. We can do that any day in the DSI. So please stay with us and enjoy the refreshments are in the other room and continue the discussions. And don't forget, I know, what would I do without you? When you leave, please complete the back of your badge and put it in the collection receptacle at the reception, at the registration. Silver troughs outside the door, it's very important. And surveys will be coming. So again, enjoy the reception and thank you very much for coming.